This is evaluating limits using tables and graphs. So let's say we had this rational function here. We've got f of x equals x cubed minus 1 over x minus 1. And we wanted to take a look at what was going on around x equals 1. Well, what we're going to do to investigate that is make a table of values. So we're going to have values of x, and then our function values. And again, we're looking around x equals 1, so we're going to put 1 in the middle. And then maybe let's look at 3 values on the left and 3 values on the right. And we'd like to get really close to 1. So maybe we start off with 0.9, and we can get closer with 0.99, and even closer with 0.999. Now, if we wanted to, we could add more values between 0.999 and 1, but this will suffice. Now, if we look at the right side, maybe we try 1.001, 1.01, and then 1.1. Now, the way we find the function values is we just substitute. So if we want f of 0.9, we would plug in 0.9 cubed minus 1 over 0.9 minus 1. And we would use our calculator for this, but you're going to get values that look like this. These are all rounded. This is 2.710, 2.970, and 2.997. On the other side of 1, you're going to get 3.003, 3.030, and 3.310. Here at 1, we know that this value is undefined, but we're not so concerned with what is happening at x equals 1. It's what happens as x gets close to 1. So here, as x is getting closer and closer to 1, it looks like f of x is getting closer and closer to 3. Same thing from the other direction. As x is getting closer and closer to 1 this way, it looks like f of x is getting closer and closer to 3. Well, that's what we call a limit. So we can say the limit as x approaches 1 of f of x is 3. So the limit of f of x as x approaches 1 is 3. And the way we would write that is limit as x approaches 1 of f of x is equal to 3. So just one more reminder that we're really not talking about what's happening here. We don't care about what happens at x equals 1. It's as x is getting really, 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 really close to 1. So here's a graph of that same function. This is x cubed minus 1 over x minus 1. And it's quadratic. We know that because if we divided the numerator by the denominator, we get a quadratic, except that this function should have a hole at x equals 1. Now 1 is just about here. Let's mark that. Right about here. So there should be a hole right there. Okay, now our graph is complete. And we are talking again about the limit of f of x. So now take note that if we kind of followed along this function, if we traced along from the left side and got closer and closer and closer to x equals 1, our function values are getting closer and closer to 3. Same thing from the other direction. If we traced along, as x got closer and closer to 1, our function values are getting closer and closer to this 3 right over here. So you see how we can evaluate a limit either by looking at a table of values, or we can look at it graphically. So this would still be 3. So here is our informal definition of a limit. The implication is that there's a formal definition, but you will see that at a later time. So here we have f of x, our function, becomes arbitrarily close to a single number L. So in our example, our L was equal to 3. So f of x is getting really, really close to L, as x is getting really, really close to C. And note that this is from either side. Remember our table and our graph, we were looking from the left and from the right. It's important that we look at both sides. So if this is true, if f of x gets close to L as x approaches C, then the limit of f of x as x approaches C must be equal to L. Okay, here's our summary. You saw the informal definition of a limit today, which is some real number L that f of x gets infinitely close to as x gets very, very close to C. And we can evaluate limits 2 ways. We can evaluate them using a table of values. When you make your table, put your value of C in the middle and choose values that are close to C from the left and from the right. And we can also evaluate our limits graphically, and you're doing this just by inspection by looking on the graph from the left and from the right.